This is a continuation of our notes from comparing numbers in scientific notation. So we're just going to go through these examples. The first two are extremely quick, and then the last two we'll do some work to figure them out. So the first two are quick because the exponents are the same. So when the exponents are the same, we are going to compare the coefficients here, and not coefficients, I'm sorry, first factors. So we're going to have 2.36 compared to 2.365. So I'm going to add another place value here. So you can think of that as 360 thousandths to 365 thousandths. So 365 thousandths is bigger. So that means that 2.36 times 10 to the fourth is less than 2.365 times 10 to the fourth. In the next one, we have the same exponents, 10 to the negative 7, 10 to the negative 7. So we compare the first factors. So I'm going to add over here place values to match how many place values we have here. So I'm going to add 2 zeros there. So you can think of that as 300 thousandths, and this is 301 thousandths. So 301 thousandths is bigger. So that means that this is a bigger number than this one. So 6.3 times 10 to the negative 7th is less than 6.301 times 10 to the negative 7th. The third one actually is just as quick. We have number in scientific notation here. This first number is between 1 and 10. We're multiplying by a power of 10. The exponent is an integer. Here we have a number between 1 and 10. The power is 10, and the exponent is an integer. So when we have this, we just have to compare the powers. So 10 to the 12th is less than 10 to the 15th. So my answer is 5.6 times 10 to the 12th is less than 4.8 times 10 to the 15th. All right, the last one we're going to have to do a little bit of work, because 34 times 10 to the negative 6th is not in scientific notation. So we're going to have to change that. We could either match the powers like I showed you in the last video, or we can change to scientific notation and then compare. So I'm going to choose to change this to scientific notation. So this negative exponent tells me I move the decimal point, which is at the end here. So let me put it there. We have to move the exponent 6 times, and the negative tells us that we have to move it to the left 6 times. So I'm going to draw my red arrow. I'm going to show that I'm moving it 6 times there. When I put the decimal point where it needs to go for scientific notation, it goes right there between the 3 and the 4. So it's 3.4 times 10 to a power. I have to decide how many times I have to move it. So the original one, I was moving 6 times to the left. But if I put the decimal point here, I only have to move it 5 times to the left. So that means my exponent is negative 5 now. Now it's time to compare the numbers. So I'm comparing 3.4 times 10 to the negative 5th with 3.4 times 10 to the negative 5th. So since they ended up to be the same, we would just put that they are equal. So 3.4 times 10 to the negative 5th is equal to 34 times 10 to the negative 6th. And that is the end of these notes.